Here's a look at my CNC machine. I've updated the X-axis to a 2 lead screw to avoid racking. You have to be really precise with the 2 screws, in this case Acme screws, because if you're not, then you wind up the gantries out of square. And so there's 2 ways to square it that I know of. One of them is a mechanical way, and then the other one is an electronic way using home switches. And in this case I have both, because I started out with a mechanical and then I went with the proper way, which was using home switches. So let me demonstrate both of those real quick. And basically I have 2 clamps. They're round clamps, and they're knurled so that I can adjust an axis by gripping it and turning it. And these actually clamp onto the Acme rod rather than using a couple of nuts and jamming them together to create a lock. Plus this is bigger than the nut, so I can grab a hold of it. Now the problem that you have if you use the nut method is that you're actually going to twist the Acme rod, because you're binding the threads together between 2 nuts, and it actually will tend to bow the rod. The reason that I know that is because I'm faced with that right now. So if we look at the rods, you can see a wobble. One of them has a lot more wobble than the other, and it's only because I've tried to tune out the wobble by moving the jam nuts. But there's a way around that, and that is to use this clamp. So I'm going to have my buddy see if he'll make me, I need 4 more of these clamps to replace those nuts on the other end. But getting back to squaring of the machine, if I bring this up, and I'm going to slowly do it, and you can watch both of those as I come around and bottom out, which is going to be right about here. There, both of them are bottomed out. You can see that one is standing almost straight up, and this one here is a little bit to the right. Okay, and so that's mechanically squared, and all it is this is bottoming out up against the nut faces, which you can see right here. There's 3 nuts that secure the anti-backlash nut onto the plate, which is attached to the gantry. And so what I've done is, by backing those up to the point where they bottom out, I've made sure the machine was square at that point. And of course now I've added some home switches, which are here, and they use a plunger type, and these are supposedly really accurate. So if I home, you can see that I home there, and I usually will do it 3 times. Notice the machine is backing off after it's homed. It backs off and then sets the DRO to 0 on the X. And took a little bit of time and some help from some fellows on the mock forum, but I was able to get this, and now you can see that it backs off enough that I am actually off of this switch. So I'm not putting any pressure on that plunger. So if I send my machine to home, it goes home, squares, and backs off of the switch, which is exactly what I wanted. I'm actually using the bearings on this end to secure the Acme rod so that I don't have any end play being put on the motors. In other words, this is taking care of any play that I have on the rod. So there's no thrust issue with the motor. It's all back there on the bearings. And again, I am going to see about getting 4 of these and replacing those nuts with these clamps. They're just like a pinch, and that way I don't twist my rod and have the bows that you see, which that is not good, because as that rises up and down, it can throw off the repeatability of your machine. Now, what's the repeatability of it? They made a little pointer on each of the Acme rods to show where it returns after it homes. And I've created a homing cycle that just repeats. So what I'm going to do is go ahead and home the machine, and this is only homing the X-axis because it's the one that has the 2 motors on it. And you can see right now the pointers are on the seam or the split, and so whenever I home, if they return back to exactly the same spot that they were in to begin with, then I know that the machine is staying square. So you can see those slits and where the pointer is, and whenever it comes back, it should line up exactly the way it was. Now, I'm going to throw it off one step, and that's throwing it off in the step in the same direction. So let's try that first. So I'm going to home, and if the machine is accurate, it will return back where it was originally and not be the one step off. And I have this do the cycle several times so that it squares the machine up to ensure that it's square. And you can see now that one is back on and that one there is back on. So now let's do it in the other direction. I'm going to do this one in this direction, and we'll do this one in that direction. And that would, in a sense, throw the gantry out of square. So again, I'm going to do the homing cycle, and we'll see if it catches up. It looks like it took twice for it to wind up, so we'll just let it go through its cycle here. And again, they should wind up with that slit on the pointer. And in fact it is. So that is how accurate I'm expecting my gantry to stay. And you can see back here where I have this lead screw attached here and this lead screw attached here, and that in a sense squares my gantry, and there is no play in it whatsoever. So again, we're just home. So this is not only homing the machine, but it's also squaring the gantry. And we should be on the pointer with both, and we are. This should be the final cut. Up against the block there. I'm just going to slide the framing square, and you can see that is perfect. I have the same gap all the way down, and if I run this square all the way up, that side is perfectly square. So we will take and go around, and let's check this side. So what I do is I run it up here, and then I slide it in, and I look at the gap as I'm sliding it in. And again, the gap is perfect. Again, sliding it down. Square is good and tight. And one last check. Here's this corner. Slide it in. And that's good. So the machine is square. One final check is to make sure the part is not skewed. So I'm going to set this right on 13. And then we're going to look over here, and we'll see that that is actually setting exactly on 5/16 at the point. And then if I do the same thing here, we're going to set this on 13, which would be right there. And then come and check. And that is exactly 5/16 from the number 4. So my block is square, the corners are square, and therefore the machine is square. Here's a look at the brackets that I made to hold the limit switches. And they are designed to have a little bit of play. This here is slotted, and these two are not. So this would actually slide back and forth in a slot there. You can see I'm about in the middle of the adjustment. And then the same thing on the other side. So, and I'm using this space to hit for the limit switch to hit. And it contacts a roller, and it also has a rubber boot, so the limit switch is sealed.